Hello students, welcome to this next lesson, lesson 2 on compounds. Okay, there's our outcomes. So we have elements and we have compounds. How do you tell the difference? Well, simply put, an element can have a capital letter and a small letter. Notice that one didn't have a small letter. Capital small. So you can see like this one here, boron, just has a capital letter, no small letter. But like nickel has a capital letter and a small letter. When you look at this though, there are two capitals, right? Whenever you have two capitals, there might be some small ones in there too. As soon as you have two capital letters, you have a compound. So a compound is more than one element that has been put together, right? Two or more elements put together make a compound. Okay, so that's a review. Let's move on to the next one. Okay, I want to talk about these things called acids. So first of all, acids contain H and are dissolved in water. In other words, they're called aqueous. AQ is this symbol, aqueous, means dissolved in water. So if a compound has an H and is dissolved in water, it's an acid. Okay, so I'm going to put up a bunch of examples. All right, so those would be acids. Those would not be, they'd just be compounds. Those would be compounds dissolved in water. Okay, let me explain it. So this compound has an H and it's aqueous. It's an acid. H, aqueous. H, aqueous. Acid. This is the same one, HI, right? It's got an H, but it does not have aqueous. No aqueous. No aqueous. It is not an acid. It could become an acid if it was dissolved in water, but it's not an acid at the moment. Okay, and same thing here. I have aqueuses all the way down, but none of these have H's. Okay, so this is the only column that we would consider acids. All right, next one. Okay, bases. Bases contain hydroxide and are aqueous, are dissolved in water. So let me put up the examples. So hydroxide is this. It's actually an OH negative, but I'm not going to worry too much about that because once it's put into a compound with like this Na positive, you don't notice the negatives and positives, and that's a whole different story. But notice we have OH aqueous, OH aqueous, OH aqueous. Okay, here we have OH, but they're not aqueous. And that's what a base is. You remember what we talked about with acids and bases in Science 14. Acids are pH of 1 to 7 on the pH scale, and bases are from 7 to 14, and acids turn litmus red, and bases turn litmus blue, and all of that stuff, right? Okay, next. There's these things called alloys. If I take copper and zinc, if I take those two metals and I melt them together, I get this new substance called brass. And you all know what brass is. You've seen it in musical instruments. There's what brass looks like. It looks like gold. You might have seen little ornaments at, on tables and such, people's houses. There's brass, okay? So you can take these two elements and melt them together and get this, two metals and melt them together and get this new substance called brass. Okay, two or more metals melted together. All right, next. Here's another one. Copper plus tin plus some others in trace amounts gives you bronze. So like sculptures. That, for example, is a sculpture down at the Remington Carriage Museum. But notice what I've got here. I took copper and I took tin. I just took those metals and melted them together, and I get this new substance called bronze, and you can tell what bronze looks like there. Okay, by the way, a little bit of town trivia. That horse and rider down at the Remington Center was turned into a movie called Seabiscuit. So that rider on there, Tobey Maguire, he played Spider-Man in one of the old Spider-Man movies. Same thing here. He played this famous jockey that rode Seabiscuit. Anyway, okay, moving on. So again, two or more metals melted together is an alloy. Okay, now I'm going to talk about these things called ionic compounds. An ionic compound is a metal and a nonmetal. So I might take this. Remember, here's our staircase line. So a metal with a nonmetal. Anytime I have that, I have what's called an ionic compound. That's different than an alloy, which was metal and metal melted together. Okay? All right, so we're also going to talk about how we name these things. So it's pretty easy. So if I had lithium and nitrogen, I would just look at their names, lithium and nitrogen. And then I would cross off, I'll say this. The name of the first element, this one, the metal, stays the same. I just write down lithium. The name of the second element, the nonmetal, ends with IDE. So I have to cross off this and put down IDE. And then I just basically, there is a space between the words, but that's how it looks. So let me just clear this screen. So I cross off the OGEN, and I've got nitride now, and I just put them together, lithium nitride. There is a space between them though. That's how you name an ionic compound. Lithium stays the same, nitrogen changes to nitride. Here's another example. If I had magnesium and chlorine. Magnesium, chlorine, drop the INE, add IDE, chloride, and there you go. Oops. All right, so you got magnesium chloride. Okay, that's how you name an ionic compound. And then there's some compounds with common names. I just want you to know them. I'll put them up all on the screen. So you probably all know that H2O, water is H2O. Carbon dioxide is CO2. Here's one you need to know. It's called methane. Okay. Here's another one called propane. Here's another one. It has a more scientific name, but we're just going to have a common name for it. Sugar. Here's another one. This is actually blood sugar or glucose. Anyway, those are some common compounds. I just want you to know what they are. Okay? And I think that is it for this lesson. Yeah, so now you're going to go on to do the questions in the booklet, and we'll move on to lesson 3.